Hello student, welcome to our lecture number 4 and 5. In this lecture we are going to discuss parallel AC circuits. By the way, the concept of parallel AC circuits is the same as the series circuit, but there are some difference in the equations. Okay, so we are going to take an introduction about it. We are going to see the parallel AC circuits, voltage divider rule, current divider rule, frequency. This is wrong here. So it should be current divider rule. Okay. Frequency response for parallel circuits. We are going to take summary of parallel AC network, homework and examples were included in the presentation. Okay. Now, what is a parallel circuit? The basic structure of a parallel AC network is provided as you can see in the figure here يا شباب. This is the parallel circuit. We know it's from circuit 1. But here يا شباب, we know that there are some angles affecting the total impedance, right? So if we have a resistor, we know that the angle of the resistor is 0, right? And the angle of the capacitor is minus 90. The angle of the inductor for the inductor is 90 degrees. Okay, so we must now find a way to determine the total impedance of such a combination so that the other elements such as the source current can be determined. Okay, Shabab? Now, before I go to this slide, I want to mention something important, which is in parallel AC circuits, we need to find the total impedance in order to find the source current. Okay, so we are going to see how to do it. We are going to see some examples, and as you can see here, this is the one of the formulas for the parallel circuits, same as the circuit 1 shabab. So this is the parallel impedance. Okay, this is the total in case of parallel, and this is again same as circuit 1 if we have two elements only. So two elements, if you have Z1 Z2, so multiply them over the sum of them. Okay, as simple as that يا شباب. Okay, now to find the input impedance, so we have here 20, okay, 20 ohm, and we have here 10 ohm as XL. Okay, so if we have two impedances, just only apply this formula, which is multiply ZR by ZL over ZR plus ZL. Okay, so you will find it, you will have it in polar form. So this is just only to remind you that we can just go to rectangular form, then to polar form. Okay, they are the same answer, but in another forms. Okay, so the total impedance diagram, the impedance diagram, this is the impedance diagram. This is ZR. We know that the angle is 0, so this is it, and the magnitude is 4 ohm, so this is 4 ohm. Okay, shabab. Then ZL is with angle 90. Okay, and this is the magnitude. Shabab, very important note: in case of drawing impedance diagram, you must use polar form. Okay, in case of impedance diagram, because we need a magnitude and angle. خلاص يا شباب. So the magnitude is 7.95, and this is the total impedance of this circuit. This is the total impedance of this circuit. Okay, don't worry about the angle now of the total impedance. We will you can see it here. We already calculated. This is the angle of the total impedance, and this is the magnitude. Now for this circuit we have 3 elements. Just apply this formula يا شباب, same as circuit 1, and you will end up with this total impedance. So here again the impedance diagram is ZR is 4.38, which is 0 angle, and ZL is 1.64 with angle 90, and this is the total impedance يا شباب. This is the total impedance. Try to practice more يا شباب about it, and you will see it is easy. Okay شباب, I'm going fast because it is the same, the concept is the same as the series. So we have impedance here, just only in parallel. Okay, now the total admittance is just only 1 over z, 1 over z. Okay, so y, this is the called admittance. Okay, y is equal 1 over z. Okay, now in case of resistive elements, so it is ZR, so 1 over R with angle 0, so it is G. Okay, G, which is conductance. خلاص يا شباب, إن شاء الله you will understand more in examples. Okay, but just this is only to show you the formulas that we need. Now in case of inductive element, just only y is equal to 1 over ZL. Now of course ZL is XL with angle 90, and this is the answer. Okay, in case of inductive element. Now the ratio 1 over XL is called susceptance. So if the inductor or inductive element is given by symbol BL and is measured in Siemens again, therefore BL is equal 1 over XL, which is YL is BL with angle minus 90. Okay, so in case of resistor or resistive load, so it is conductance. In case of inductive element, it is called susceptance. Okay, which is BL. Now for in case of capacitive element, okay, it is called again susceptance, which is BC, which is BC 1 over XC, which is this one, because the angle, so BC is equal 1 over XC. We know the angle of XC is minus 90, so this angle will go up, and BC with angle 90. خلاص يا شباب, that's why we have plus 90 in the capacitor and minus 90 in the inductor, in case you need to find the susceptance. Okay, now in case of conductance, okay, just only add by adding them directly. In case of admittance for parallel circuit, the total admittance is simply sum of the admittances. Okay, sum of the admittances. In case in any case, whether the total impedance or admittance is first found, the other can be found using the simple equation. This is the one. باختصار يا شباب, إذا قدرت تطلع Z total تقدر تطلع Y total, وإذا عندك Y total تقدر تطلع Z total. Okay, and the unit for the admittance is Siemens. Okay, S. Now let us find the admittance of parallel elements. So I have the same as the figure before, which is R equal to 20 ohm and XL is 10 ohm. Okay, same example number 1 يا شباب. The solution is YR is equal to G with angle 0, right? So G is 1 over R. Okay, so 1 over 20, which is equal to 0.05 S, which is Siemens with angle 0. Okay, so for the inductor, it's just only BL with minus 90. Now we know why minus 90, because YL is equal to 1 over XL. XL, of course, with angle is 90, right? So it will be PL with angle minus 90. Okay, that's why we have here minus يا شباب. Okay, so 1 over XL equal to with angle minus 90, and this is the answer in polar form, and this is the answer in rectangular form. Now, just only finding the total admittance is just only adding the two together. If you find this is the total, okay, this is the total admittance. This one is the conductance G, and this is the part of the P, okay, which is the susceptance, okay, which is the susceptance, and this is for the conductance part, which is the resistor, and this one is for the inductor part, which is the inductor. Okay يا شباب, this is as a magnitude here, this is the magnitude of the total admittance, and this is the its angle. With more examples, inshallah, you will understand. Now, as you can see here, we can define a current divider rule, and we can use it. This is just only one example because you already have taken it in circuit 1, so no need to repeat. This is the current in this branch. Okay, shabab. If I want to find the current in this branch, IR, through the resistor, I need to apply this formula. So IR is ZL multiply I total over ZR plus ZL. Okay, this is the formula. So in case I need the current in this part, so I multiply this ZL multiply the total current over the sum of the two. Okay, shabab. If I need to find the current in this part, so IL, so I will use this ZR multiplied I total over ZR plus ZL. Okay, as simple as that, shabab. Now, for the frequency response for sorry, again here is I am mistaken for the parallel. Okay, parallel here, parallel. The frequency response, again, you need to understand one thing, okay, which is for parallel elements, it is important to remember that the smallest parallel impedance, okay, parallel impedance will have the most impact on the total impedance, will have the most impact. يعني أكثر واحد يأثر هو اللي عنده أقل impedance في البارallel circuits. Okay, شباب. Now, as you can see here from this picture, okay, we know that in case of low frequency, and we have the three elements R, L, and C, okay, for the XL will not have will have low impact on the circuit in case of low frequency. So the XL will have low impact on the circuit in case of low frequency, and this is not correct for the capacitor. The capacitor will have the most impact on the circuit in case of low frequency, so it is opposite. خلاص يا شباب. And this explanation you can find it here. Read this one and you can find it. Okay. Now, try to read the summary of the parallel AC network and be familiar with it. Okay. If you have any question, you can ask me in the inshallah discussion. خلاص يا شباب. Now, this is the homework. I need you to find the total impedance, okay, seen by the source, and you can find the using the result of part A, find the total admittance. So we know that impedance is Z, admittance is Y. Okay, sketch the admittance diagram. this is very important. Admittance diagram. Determine the source current. Okay, calculate the current through the capacitive element. Okay. Yeah, you can write the expression. You can write the expression, sensor the expression for the applied voltage and source current. Yes, you can apply the same formula for the power factor of the network, and is it leading or lagging? Okay. And is this considered as a capacitive or inductive configuration? And you can find here the solution, the final answer. Please try to have a look at this homework and do it by yourself to inshallah do well in the exam, inshallah. Thank you so much for attending this lecture, and I am going also to download again, download it in the Blackboard, inshallah. You can see the link also for lecture 6 and 7. Thank you so much and stay safe.